Okay, in this video, we will go ahead and review how to simplify algebraic expressions using exponent, radical, and rational rules. So looking at the first example, we have to multiply the coefficients 2 and 4. 2 times 4 is going to go ahead and leave us with positive. Let me just delete this real quick. So we have 2 and 4. We multiply them, and that will end up giving us positive 8. Then we multiply x and x. Keep in mind that the power rule for exponents indicates that if we ever multiply two variables with the same exponent, two variables that are the same, we add the exponents together. So I have times x to the 3 plus 7, that's going to give us positive 10. Then we have times y to the what? Well, we know that y, when there's no exponent, it's known to be a 1. So we have y1 and times y to the negative 2. So we add those two exponents together. 1 plus negative 2, that gives us negative 1. Now, we cannot have negative exponents, so I will go ahead and bring down that negative exponent down below. So we should have something that looks like this. We should have the positive 8 remains the same, times x to the 10th, that remains the same, times 1 over y to the first power. Now, do we need to write down y to the first power? No, we know it's known to be a 1. So the final solution is going to look something like this. We have 8x to the 10th on the numerator, all divided by y. And that's going to be the final solution. Or you can also write it down as 8 times x to the 10th divided by y. It's the same format. Let's go ahead and box this one in. Moving on to the second example, we have division. Keep in mind that if you ever have division between two variables, you have to subtract the exponents if the bases are the same, if the variables are the same. In this case scenario, let's go ahead and begin with the coefficients. We have 6 and 2. 6 divided by 2 will end up giving us 3. Then we have x to the 4th divided by x to the 7th. So we will subtract the exponents like this, 4 minus 7. So we have x to the negative 3 times y to the, we have y to the 5th and divided by y to the 3rd. So we have 5 minus 3, which will give us positive 2. Keep in mind that I cannot have a negative exponent. Hence, we can go ahead and rewrite this to be 3 times 1 over x to the 3rd times y to the 2nd. Now from there, we keep all the terms that have a positive exponent on the numerator. So this gives us what? 3y to the 2nd divided by x to the 3rd. And that's going to be our final solution. For the next one, we have an exponent next to a parentheses. If you ever see this, you have to multiply. So you're going to multiply this exponent to the exponent right here, which is a 1, to this 4, and to this 2. So now I have 2 to the 4th power times x to the 4 times 4 gives us 16 times y to the 2 times 4 gives us positive 8. And from there, we can simplify further. So this 2 to the 4th means what? 2 times 2 times 2 times 2, which will go ahead and give us 16. So we have 16 times x to the 16th times y to the 8th. And that's going to be our final solution. Let's box it in. Moving on to the next example, we have the following. And again, we have to multiply this exponent negative 3 to every single term. So I have 3 to the negative 3 times I have x to the negative 4 times negative 3, that gives me positive 12, times y to the 2 times negative 3, that gives me negative 6. And again, I cannot have negative exponents. So I will rewrite this to be 1 over 3 to the power 3 times 1 over x to the 12 times 1 over y to the 6. From there, I have a fraction times a fraction times a fraction. And the idea is what? Fractions, for fractions being multiplied, we have numerator times numerator, denominator times denominator. So we have 1 on the numerator, all divided by 3 to the third times x to the 12 times y to the 6. Can I simplify this further? Yes, I can. The 3 to the third power represents what? 3 times 3 times 3, which will go ahead and leave us with a final solution of 1 all divided by 27 times x to the 12 times y to the 6. And that's going to be our final solution. Let's move on to the next example. For the next example, this one's a little bit more difficult. For this one, I would recommend that you simplify everything that you can within the parentheses and then work with the outside exponent. In this case scenario, I have 4 divided by 16, and that's going to leave me with what? 1 over 4. If we simplify that, right, 4 over 16 gives us 1/4, times, then we have x to the first power divided by x to the 7th, which means what? That we have x to the 1 minus 7, that gives you negative 6, times we have y to the, well, we have y to the negative 5 divided by y to the negative 3. Now for this one, that's going to turn into what? Instead of subtraction, right, you have to convert that to addition. So this can be rewritten as follows. We have equals 1 over 4, that does not change, times the x to the negative 6, don't worry, we will change that in just a little bit, times y to the negative 5 plus 3, and that's going to give us what? Y to the negative 2. So let me just erase that real quick. Y to the negative 2. Okay, and now for the negative exponents, since we can't have them, we have to rewrite them. So this is going to give us the following. 1 over 4 remains the same, times, give me a second. Wrong number. Okay. Then we have 1 over x to the 6 times 1 over y to the 2nd. And then we put it all together. So this will give us a final solution of 1 divided by 4 x to the 6 times y to the 2. But do not forget about the exponent too. So we still have that exponent too. Let me just wrap everything to the second power like this. Okay, and now we distribute that exponent. So this is going to end up giving us what? 1 to the second power, all divided by 4 to the second power, times x to the 12, times y to the 4th. And this will be simplified to be what? 1 to the second power is 1 times 1, which gives us 1, all divided by 16, right? 4 squared means what? 4 times 4, that's 16, times x to the 12, times y to the 4th. And that's going to be the final solution. Let's go ahead and box it in. Moving on to the next example, we have to convert to the rational exponent. Now, here's my recommendation. I always use the following phrase, top in, bottom out. So let's say, for example, let's write an additional example right there. Let's say that I have x to the, let's say, 3 over 7, okay? I will use the phrase top in, bottom out. So this is my top, and it's going to be inside the radical, and this is going to be my bottom. It's going to be outside the radical. So that's where I get that phrase top in, bottom out. So this is pretty much the same thing as saying this. We have a radical, right? we have our base, x. The exponent is going to be 3, right? Top in, bottom out. And that 7 is going to be right there, which indicates that we have the 7th root of x to the 3rd. Okay? Now, using that idea, we're going to convert this into a rational exponent. Keep in mind that the exponent here is a 1, right? Since it's not written down. So that's my in. That's my top in. And this 3 is my out, bottom out. Okay? Based on that, this can be rewritten as x to the 1 over 3. Moving on to the next example, we have the exponent of 1. And if it's not written down, this is a 2. Okay? So based on that, that's my in. And that's my out. So based on that, I have x to the 1 over 2. From there, for this one, I have the 5th root of k to the 2nd power. So again, this is my in. That's my out. So top in, bottom out. This is going to be converted to be k to the 2 over 5. And that's my final solution. Let's go ahead and box them in. Okay. And let's go ahead and apply that rule for these two next examples, converting to the radical form. So again, this is my top in, right? Bottom out. So this is going to turn into the radical of x to the 3rd and a 2 outside. So this is what? The square root. So we have the square root of x to the 3rd as my final solution. For the next one, I have this to be my in. I have the 4 to be my out. So I have the radical of a to the 5th and 4 outside. So it's going to be the 4th root of a to the 5th as my final solution. Let's jump down. Then we have to convert to the radical form and simplify. So looking at this one, we have 9 to the 1/2. Again, the idea is what? Top in, bottom out. So this turns into what? The radical of 9 to the 1st power and 2 outside, which essentially is what? The square root of 9. And what is the square root of 9? Well, it's going to be plus or minus 3. All right, let's box that in. And then for the next one, same idea. This is my in. This is my out. So I have the radical of 8x to the 1st power and 3 outside. So this is the cube root of 8x. Now keep in mind that you can always split a radical up, but only if you have multiplication. We know that if we have a number next to a variable, it's always multiplication. So this can technically be rewritten as the cube root of 8 times the cube root of x. And we know that the cube root of 8 is what? Well, we need the same number when multiplied by itself 3 times will give us 8. In this case scenario, it is what? 2, right? 2 times 2 times 2 will give us 8 times the cube root of x. And that's going to be our final solution since we cannot simplify the cube root of x any further. Now, you might be asking, how come we don't put a plus or minus for this one and we put a plus or minus for this one? Well, keep in mind that if you have an even power, let me zoom in. If we have an even power compared to the odd power, if it's an even power, you have to write down plus or minus for the solutions. But if you have an odd power, such as 1, 3, 5, 7, and so on, then you don't have to write that down. So let's write that down. Don't write plus or minus for the solutions, okay? Even powers would be what? 2, 4, 6, and so on. Okay, all right, so now based on that, we're going to jump into some additional practice questions. Let's look at the first one right here. So we have the following, and this is what I will do first. I will multiply the coefficients first, so 3 times 5. That will go ahead and give me positive 15. Then I multiply the variables with each other, x to the second times x to the third, and keep in mind that if they're the same variable, then you have to add the exponents together. So this will give me x to the 5th power. Then for the y's, I have y to the first times y to the negative 4. And I do what? I add the exponents, and that's going to give me y to the negative 3. But again, I cannot have a negative exponent. So I will rewrite that to turn into 15 times x to the 5th times 1 over y to the 3rd. Then I can rewrite this, correct? So I keep all the terms that are by themselves on the numerator and the denominator terms by themselves. In this case scenario, my final solution will be 15 x to the 5th, all divided by y to the 3rd. Let's go ahead and box that in. For the next question, I have the following. I will begin by multiplying the coefficients together. I have 4 and 3, so that will go ahead and give me, what, 12. Then I will multiply the x's. Keep in mind the order doesn't matter, but I always recommend that you write them down in alphabetical order. And I have times x to the 3rd. There's no other x, so I leave it alone. Times y, right? I have y to the 1st, so y to the 1st times y to the 5th will give me y to the 6th. Can I simplify this any further? No, the final solution will just simply be 12x to the 3rd and y to the 6th. And that's going to be the final solution. For the next question, I have to do what? Well, I have to multiply the coefficients first. There's a 1 right here. If it's not written down, it's always known to be a 1. So I have 1 times 9. That's going to give me positive 9. Then I have the following variables, x, and I add the exponents. So I have x to the 10th power times y to the, what? We have y to the negative 3 times y to the negative 10. That's going to be what? Y to the negative 13 if we add them together. Keep in mind that we cannot have negative exponents, so we will rewrite this to be 9 remains the same times x to the 10 remains the same times 1 over y to the 13. And this will give us a final solution of 9x to the 10th on the numerator, all divided by y to the 13. Okay, now let's move on to the next question. For the next one, we have division, right? We have division between these two expressions. So I have the coefficients 10 divided by 5, and this will give me what? 10 divided by 5 gives me 2. Then I have x to the 3rd divided by x to the 7th, and I do what? I subtract the exponents. So I have times x to the negative 4 times, for the y's, we have y to the 4th divided by y to the 2nd. So we subtract the exponents, and this will leave us with y to the 2nd. Then I simplify. I cannot have negative exponents, so this will simplify to turn into what? 2 remains the same, times 1 over x to the 4th times y to the 2nd. This will then give me a final solution of 2 times y to the 2nd, all divided by x to the 4th as my final solution. Let's go ahead and box it up. Okay, moving on to the next question. Again, we have to simplify this expression in which we have division. So we divide 10 and 15 together. That's going to give us, what, 2 over 3 if we simplify further. Times, we then divide x to the 5th divided by x to the 2nd, and we subtract the exponents. So I have x to the 5 minus 2 gives me 3 times y to the, we have 7 minus 3. That's going to go ahead and give us 4. So we can leave our solution in this format, right? We have 2 thirds times x to the 3rd, y to the 4th. Or we can rewrite this to be 2x to the third, y to the fourth, all divided by 3. Either format would be correct. Okay, let's move on to the next one. Again, I have division right here, and I begin by dividing the coefficients. I have 4 divided by 2. That's going to go ahead and give me positive 2. I then divide the x's. I have x to the third divided by x to the fourth. That's going to be x to the negative 1. Then I have times y to the, we have to the fifth power divided by y to the seventh power. So that's going to turn into negative 2. And again, I do not want negative exponents, so I will go ahead and place them down below. So I have 2 remains the same, times 1 over x to the first power, times 1 over y to the positive second power. Keep in mind that we do not need to write down the first power, so the final solution for this one will be 2 all divided by x to the first power times y to the second, and that's going to be my final solution. For the next question, we have the following idea. Keep in mind that for this one, we have to distribute the exponent 3. We have to multiply to every single term. So we have 3 to the third power times, we have x to the, 2 times 3 gives us 6. And then for the y, we have y to the 2 times 3, that's 6. And then we simplify further. We know that 3 to the third power is going to turn into 27. And we keep everything else the same, x to the 6, y to the 6. And that's going to be the final solution. For the next problem, same idea. We have 4 to the second power times x to the 3 times 2 gives us 6, times y to the 5 times 2, that gives us 10. And then we simplify from there. We have 4 to the second, that gives us 4 times 4, which is 16, times x to the 6 times y to the 10th as the final solution. Let's go ahead and box it in. Okay, for the next question, we have the following. And again, same idea. We have 2 to the fourth power times, we have x to the negative 3 times 4 gives us negative 12. Then we have times y to the 7 times 4, that gives us positive 28. Okay, and then from there, we simplify further, and 2 to the fourth power will go ahead and give us 16. So we have 16 times 1 over x to the positive 12 times y to the 28. And this will simplify further to give us 16 remains on top, y to the 28, all divided by x to the 12. Okay, let's move on to the next question type. And for this one, we have a negative exponent outside the radical, hence we have to multiply. So we have 2 to the negative 3 times x to the negative 6 times y to the negative 6. And again, I cannot have negative exponents, so I will rewrite this to be 1 over 2 to the positive 3 times 1 over x to the positive 6 times 1 over y to the positive 6. And from there, I put all of this together. This is going to give me 1 on top. The 2 to the third turns into positive 8 times x to the 6 times y to the 6 as the final solution. Let's box it up. For the next one, same idea, but we have a negative exponent, so watch out for that. We have 4 to the negative 2 times, we have x to the negative 8. We then have times y to the negative 14. Okay. And again, I cannot have negative exponents, so I will rewrite this to be 1 over 4 to the positive 2 times 1 over x to the positive 8 times 1 over y to the positive 14. And from there, I will then combine all the terms together. I have 1 for the numerator for all terms. 4 to the second power will give us positive 16. Then we have x to the 8th power. Oh, and excuse me, there's an error right there. And that should have been, let's see, that should have been y to the positive 14. Let me fix that real quick. There we go. All right, so that should be times y to the positive 14. So if that's the case, then that means that we don't have to write the 1 there. We can just simply write down y to the, y to the 14th. Okay, there we go. Okay. Okay, now moving on to the next question. For this one, same idea. We have a negative exponent, so we have 5 to the negative 3 times. We have x to the positive 15. Then we have times y to the positive 15th right there. Whoops, I think I made a mistake right there with the x's. That should be a 9 right there. Okay. And then I simplify. So this is going to turn into 1 over 5 to the positive 3 times x to the 9 times y to the 15th. And I put all of this together. So this is going to give me a final solution of x to the 9th, y to the 15th, all divided by 5 to the 3rd. That's going to give me what? 5 times 5 times 5, which is 125. And that's going to be my final solution. Okay, let's move on to the next one. Okay, for this one, my recommendation is to always do everything that you can inside the parentheses. So I have 4 divided by 8. That's going to simplify to turn into 1/2. So I have 1/2 there. Then I have times x to the what? We have 3 minus 5. That gives me negative 2. Then I have y to the, we have 5 minus 7. That's going to go ahead and give us negative 2 as well. And we have all of this wrapped in parentheses to the second power. From there, we simplify further ahead. We have 1 over 2 remains the same. And that turns into what? X to the negative 2 turns into 1 over x to the 2 times 1 over y to the 2, all to the second power. And this can be simplified further to be what? 1 over 2x to the second, y to the second, wrapped in parentheses to the second power. And from there, I can distribute the exponents, and I have what? 1 squared all divided by 2 squared x to the 4th, y to the 4th. And this is going to simplify to turn into what? 1 squared turns into 1, all divided by 2 squared. That gives you 4, x to the 4th, y to the 4th as the final solution. Let's go ahead and box it up. Moving on, for this one, I have to do the same idea. I divide the coefficients first. So I have 4 divided by 2. That gives me 2. Then I have x to the 5th divided by x to the 3rd. That will give me x to the 2. Then for the y's, I have 8 minus 6. That's going to give me y to the second power. Okay. And then I wrap everything to the negative 3 power. And this will give me what? 2 to the negative 3 times x to the negative 6 times y to the negative 6. And then that can be rewritten to be what? 1 over 2 to the positive 3 times 1 over x to the positive 6 times 1 over y to the positive 6, which is equal to what? We have 1 over 8 times 1 over x to the 6 times 1 over y to the 6. And from there, we can go ahead and say that the final solution is going to be 1 over 8 x to the 6, y to the 6 as the final solution. Okay, moving on. For the next one, again, we begin by dividing the coefficients first. So we have 25 divided by 5. That's going to go ahead and give us 5. We have for the x's times x to the 5th power. For the y's, we have 8 minus 6. That's going to give us y to the 2nd. And then all of this wrapped in parentheses to the second power, which is going to give us what? 5 to the 2nd times x to the 10th times y to the 10th. And this is going to be simplified to give us what? 5 to the 2nd is going to be 25. So we have 25 x to the 10th times y to the 10th as the final solution. Okay, for the next one, we have to convert to the rational form. So for this one, remember the top in, bottom out. So this is my exponent inside. This is my exponent out. So that's my in, that's my out. So this will be simplified to turn into x to the power 1 over 4. For the next one, we have this as the in, this as the out. So I have x to the 3 over 5. For the next one, I have a 1, I have a 2 right there. So this will turn into x to the 1 over 2. Okay, let's move on. All right, so now for the next question type right here, same idea, top in, bottom out. So this will turn into, this is my in, that's my out. So I have the radical of x to the 4th and a 5 outside. So this is the 5th root of x to the 4th. For the next one, I have top in, bottom out. So that's my in, that's my out. So I have the radical of x to the 7th and a 12 there. So this is the 12th root of x to the 7th. For the next one, I have top in. So this is my in, this is my out. So I have my radical, and I have x to the 1st and a 3 outside. So this is the cube root of x. Okay, now we have to simplify these constants right here. So again, we still use the same idea, top in, bottom out. So this is going to be the radical of 27 to the 1st power and a 3 outside. So this is the cube root of 27, which is going to go ahead and give us 3, right? 3 times 3 times 3 will give us 27. And then for this one, we have what? Top in, bottom out. So this is going to be the radical of 81 to the 1st and the 2 outside. So this is a square root of 81, which is going to go ahead and give us plus or minus 9 as the final solution. For the next one, we have a 64x to the power of 1 over 3. So we have the radical of 64x to the 1st power and then a 3 outside. So this is the cube root of 64x. So this is going to be split apart, right? Cube root of 64 times the cube root of x. And that's going to turn into what? 4 times 4 times 4, which means that 4 is the cube root of 64 times the cube root of x. Okay, now we're moving on to the next question. For the next one, we're multiplying. So we have the x and the x. That's going to go ahead and give us what? X to the 5th. Then for the y's, we have y to the 1st times y to the negative 4. That's going to turn into y to the negative 3, which will then simplify to turn into x to the 5th times 1 over y to the 3rd, which will give us a final solution of x to the 5th divided by y to the 3rd. For the next one, we have x to the 6th, before we do that, we multiply the coefficients first. So that's a 1 right there. So we have 9, and then for the x's, I have x to the 6th times x to the 3rd. That's going to be what? Times x to the 9th. Then for the y's, I have y to the 3rd and y to the negative 10. So that's going to turn into y to the negative 7. Okay, and this is going to go ahead and simplify to turn into 9 remains the same, x to the 9th remains the same, times 1 over y to the 7th, which can be simplified to give us 9 to the x to the 9th divided by y to the 7th as the final solution. Okay, moving on to the next one. Again, we begin by multiplying the coefficients. We have 4, we have 6. That's going to go ahead and give us 24. Then we have the x to the 1st times x to the 3rd. That's going to give us x to the 4th power. Then for the y's, we do not have any more y's, so it's going to be y to the 5th. So the final solution is going to simply be this. For the next one, we have division. So we have to subtract the exponents. So we have x to the 3rd divided by x to the 7th. That's going to go ahead and give us x to the negative 4. Then we have times y to the 4th times y to the 2nd, divided by y to the 2nd. So that's going to be what? Y to the 2nd right there. And this is going to give us a final solution of 1 over x to the 4th times y to the 2nd, which is going to give me this solution, y to the 2nd divided by x to the 4th. Okay, for the next one, same idea here. We have x to the fifth divided by x to the second. That's going to give us x to the third. Then we have y to the fourth divided by y to the second. That's going to give us y to the second right there. And that's going to be my final solution. For the next one, we have 7 on top and a coefficient of 1 down below. So we have 7 divided by 1. That's going to go ahead and give us 7. Then for the x's, I have x to the sixth divided by x to the second. That's going to give us x to the fourth times y to the, we have y to the negative 2 divided by y to the positive 2. So that's going to be what? Negative 2 minus 2. That's going to give us negative 4. So watch out for that one. And we can simplify this further to turn it into 7 times x to the fourth remains the same times 1 over y to the fourth. And this is going to give us a final solution of 7x to the fourth divided by y to the fourth. Okay. Then we have the following. We multiply the coefficients first. So we have 4 and 2. That's going to turn into positive 8. Then for the exponents, or for the x's, we have times x to the fifth power. Then we have times y to the seventh power. Keep in mind that all of this is wrapped in parentheses to the second power. So this is going to turn into what? 8 to the second times x to the 10 times y to the 14th. And this is going to give us a final solution of 64 times x to the 10 times y to the 14th. We don't have to put that little times right there. There we go. All right, moving on to the next question. Same idea. You got to watch out for the exponent that's outside. So begin by multiplying the coefficients right here, 2 and 8. So we have positive 16. Then for the variables, we have x to the fifth, x to the second. That's going to give us x to the seventh. Then for the y's, we have y to the 9. And then all of this wrapped in parentheses to the second power. That's going to give us 16 to the second times x to the seventh times y to the, or excuse me, not y to the seventh, y to the 14 times y to the 18. Okay, and this is going to go ahead and give you a final solution of 256 times x to the 14th times y to the 18th. Okay, for the next one, we have the following. We multiply the coefficients first. We have 2 and 4. That's going to go ahead and give us positive 8. Then we have times. We have x to the negative 4 times x to the fifth. That's going to go ahead and give us x to the positive 1. Then we have times y to the 7 times y to the second. That's going to give us 9. And then all of this wrapped in parentheses to the third power. That's going to give us what? 8 to the third times x to the third times y to the 27. And this is going to give us a final solution of 512 times x to the third, y to the 27th as the final solution. Now for the next part, we have an exponent that's a fraction. So we have fractions that are being multiplied. So numerator times numerator, denominator times denominator. And that's going to go ahead and give us x to the 1 over 2 times 3 gives you 6. And then we convert that to be what? Top in, bottom out. So that's going to be the radical of x to the first, right? We don't have to write to the first. And the 6 outside. So this is the 6th root of x. For the next one, again, we multiply the exponents right here, numerator times numerator, denominator times denominator. That's going to go ahead and give us x to the 2 times 1 is 2, divided by 5 times 2. That gives you 10, which can be simplified to be what? X to the 1 over 5, which means that we have the 5th root of x. For the next one, we have x to the 2 times 1. That gives us 2 divided by 3. And that can be simplified further to be what? Top in, bottom out. That's going to be the radical of x to the second and the 3 outside. So this is the cube root of x squared. Okay. All right. I think this is a good stopping point. For this part, I'm going to say that you have to go about this part yourself. We did several examples, and hopefully you can go about doing these.